Batteries included comes from a different aspect of the design. Is basically saying I want the tool chain to just contain everything, right? I don't want to need to install the compiler and the package manager and the linter and the formatter and the ID extension and like the reality that's as we're designing and building this new programming language, we're trying to think in a modern way, right? Like, and kind of looking back at the JavaScript and TypeScript ecosystems, and I'm like, oh my god, this is horrible. You want to get started with a project, you need like 10 different tools and combine them together with these like intricate configuration files, just in order to build this, just to get started. And so that's where this is coming from. Like, it's like this needs to be batteries included in the sense that it's you don't need to go to the shop and get that.
Elad Ben Israel, welcome back to Software Engineering Daily.
Thank you. Thanks for having me back.
It was really nice speaking to you last time. Time flew, so I'm glad we made this a two-parter. So last time we ended kind of at a natural stopping point, just when you left Amazon, and I think we were just talking about the CDK and the main topic, the supposed main topic, which was of course Winglang, the programming language for the cloud. So what made you decide that the world needed such a thing?
So I feel like, throughout my career, my focus has always been to like figure out what's the best tool to build software. And I think like the CDK was a very, very natural step in that direction of being able to use programming languages in order to define the infrastructure and manage the complexity of your infrastructure using high-level languages. And after I left Amazon, I started, talking to lots of people in my network from across the industry and trying to understand, how people are building stuff on the cloud. I had a very narrow view of like how Amazon's doing it, how AWS is doing it, how AWS's customers are doing it. And we all know that, this industry is very diverse and there are many different technology stacks. Different cloud providers have different approaches. Companies have different approaches. And there were a few things that I learned as I was talking to people. One is that not everybody can be like Amazon in a way. I feel like that's a very, like at Amazon, there's no DevOps. Engineers basically own their entire stack. Every team has full responsibility on the entire stack, and developers are expected to understand all of the layers. And so they understand how VMs are provisioned, how VPCs are configured, how
Isn't that
deployment
exactly
works.
what DevOps is?
That's exactly what DevOps is, but there's no separate role, right? Like there's no
dedicated DevOps team.
Yeah, there's no dedicated DevOps
I
person,
see.
right?
Yeah.
Uh,
Which is arguably the most DevOps way to be, to not have a DevOps team.
right. Some would argue that this is what DevOps is about, right? Like it's basically this idea of developers doing the operations and the rest of this stuff.
Yeah.
But to be honest, I feel like it works really well for a company like for Amazon and AWS, because AWS is building infrastructure, right? Like the services that AWS are offering are infrastructure services for all intents and purposes, and eventually it makes sense for developers there to have this full understanding of the stack, because in many ways they're building those services. But as you start talking to companies like companies that are building applications, you realize that doesn't really make total sense for a company like Fiverr or like Netflix or like YouTube or
Yeah,
or
a SaaS company. Yeah.
like SaaS companies, consumer companies. in those or financial company,
and just smaller companies, because you need quite remarkable skill sets if you want every one of your engineers to understand the whole depth of the stack. And I suppose Amazon can afford to do that because they have the reputation, they have the money, they have the reach to find, hire and retain those people, whereas a smaller company certainly would not.
Yeah, I think that it's not even about the people in a sense. It's more about the focus of the engineering team. Like if you think about the engineering teams at Airbnb, right? Like the developers, the application developers, their problem space is apartment rentals, right? Like they have to create a software model to support this business, right? And so the problems that they're just trying to solve is how do we design a system that will support this business, right? Like to support the various use cases, to support the complexity of tax calculations across different territories and refunds, and there's an immense amount of software that's responsible to support this business. And they don't really need to they don't really want to care about how the network operates behind that service, right? Like that's not an interesting thing for the developers at Airbnb. It's not that true for AWS teams, right? Like when an AWS team builds, when someone's building DynamoDB, right? Like it's a very different level of the stack, right? They're not building an application, they're actually building infrastructure. So it's not just about finding the right people or having the privilege of it's more about how you design how you focus, and by the way, Amazon.com, the retail side of Amazon, is very similar to Airbnb in that sense, and we talked about it last time a little bit, is that most of the retail business at Amazon, when I was there at least, was somewhat decoupled from the DevOps side, from the operational side, because they were building Java servers, right? Like, and when you're building a Java server, basically your application is this Java thing that runs on multiple machines, and that's it. There's not a lot of infrastructure involved in that, right? In a sense, the boundary is really clear. And so that was really important to understand, because I feel like what we're seeing in the cloud industry today is, and I can't recall if we talked about it last time or not, but we're basically seeing that the cloud is still in early adoption. It's kind of mind-blowing in a way, right? Because we're all, we all think that everybody's already in the cloud and all companies have moved already, but most of the IT spend globally is still not in the cloud. Like I think last time I checked was like over 80% of the IT spend is still in, private data centers and internal, and so it's really interesting as people are trying to help developers use the cloud, is to try and understand why is that, right? Like what's the reason? And I think that there are multiple reasons, but I think one of the reasons is that it doesn't make sense for a team at a financial institution that builds a tax calculation system or at Airbnb to have to understand all these layers, right? Like you said.
Yeah.
It doesn't make sense economically. It's also a very different role, right? Like if you think about it, the passion for doing infrastructure and the passion for building applications, for building software is not the same thing. Some developers share, are kind of like in this, they have both passions in a sense. I'm one of those people, right? Like I feel like I'm excited about configuring a VPC in the same way that I'm excited about, architecting a distributed system.
Yeah.
But I think most developers really don't have that same connection to all of the layers. And throughout the history of computing, we've been able to actually decouple those things so that people who are great at doing one thing don't have to do the other thing, and vice versa. And I think what happened with the cloud is that it kind of forced us to, in a sense, the DevOps movement kind of created this middle role where you're connecting, you're gluing those two those two layers together into a single person. And again, some people can do it very well, but it's kind of like the full stack movement at some point where everybody was, yeah, from now on everybody's going to do full stack front end and back end, and slowly we're kind of waking up from that idea and realizing doing great front end is not the same as doing great back end, and you can maybe start like that, but as your system grows and becomes more complex, it's a very different mindset. And people who are very good at like pixel perfect aesthetics and designing the creating beautiful front ends, they're not going to be the same person who's really good at like designing a distributed system that's going to be highly effective and blah blah blah, right? So I feel like it's okay to realize that there are multiple disciplines, engineering disciplines, that are involved in delivering an application for the cloud, a system in the cloud, and it's really important to make sure that each one of those disciplines has the right set of tools and can work at their own layer. And what I've seen is that basically we've removed that layering, right, with this idea of DevOps and full, I would say, full backend kind of approach. So that was one interesting observation. I think the other interesting observation was that it doesn't really matter how companies, which platforms people used, which tech stacks they used, what was the organizational structure internally, whether there was this centralized DevOps team or DevOps people in every team or a platform team, or if you kind of like take a step back from that, you see that same pain exists across the industry. And the pain was that people feel very disempowered to deliver to the cloud. As the company grows, as the system becomes more complex, you get into this kind of deadlock feeling where in order to deliver something, you're really dependent on either knowledge that doesn't belong to your layer, right? Like, oh shit, now I have to understand how a VPC works, right? Like, and I actually had that experience when I first used AWS VPC. I was like, we were working on this project, and I was asking this one of the engineers in our team to install Elastic Cache Redis, and Redis required a VPC. And so he comes back to me and he says, well, we need a VPC for that. I was like, okay, great. Just, add a VPC to our CloudFormation template. And after a week, he comes back like sweating, literally. And he shows me like a set of 40 resources that are required just in order to set up a VPC, right? Like the default simple VPC for using Elastic Cache. And I was like, no way, this is so complicated. And as I dive deeper and deeper, I was like, oh shit, this is actually how AWS expects people to define a VPC. It's like all the subnets and NAT gateways and routing tables. And, granted, it's a very powerful tool, but I don't care about this, right? Like, just give me a VPC so I can use my caching system. And so I feel like this pain of disempowerment, this pain of not being able to kind of deliver quickly and stay in your creative flow as a developer, the requirement to always go and deploy something to the cloud in order to test it, to me is horrible. Like I we talked about it. Like when I was a kid, I used to, write code in Borland C++, and I could see results within milliseconds, right? Like I would just like write some code, run it, and see how it works. I lost it in the cloud.
Yeah, the feedback loops become bigger.
Yeah, it's like minutes, sometimes 15 minutes, 10 minutes before I can see what's going on. Or I have to call my DevOps team to provision a bucket or provision a queue and then people have to understand exactly how to wire up the IAM policies so that it works. And if it doesn't work, they would just like put ***, and then eventually someone will freak out.
Yeah. Or 1 time out of 5, something else in your pipeline will break, which is not the thing you care about, but you need to drop everything and fix it in order to continue developing stuff that you're actually doing. Yes, absolutely.
Exactly. And so I kind of realized the problems are kind of ubiquitous. It doesn't matter how you use this new amazing thing we call the cloud. Um, this pain is very evident across the industry. And for me, it was like, okay, so, I'm as I said, for me, it's like, okay, so what's the right, where is the missing tool, right? Like, I feel like we're not using the right tool. One of the things that I remember as a kid, I used to work in the garden with my dad a few weekends, and he was constantly hammering, pun intended, constantly telling me, you got to use the right tool. First, find the right tool before you do something. Because I would always like, oh, I have this thing in my hand right now. So I'm just going to use it to open the screw, but it's not the right, you know what I'm saying? So I constantly had this like thing in my head. It's like, okay, you got to use the right tool to do the job, because otherwise it's going to be extremely inefficient. Like, so this gut feeling as a tool builder, as a maker, it's like, I don't have the right tool in my hand. And eventually, we see this industry, you see the industry trying to solve many of those pains in different ways downstream throughout the development life cycle. Some folks are building really cool ways for you to run your Lambda function locally and debug it through a proxy on the cloud, so that they're solving the specific problem of being able to, iterate on the piece of code that you're just writing right now. Or some people are trying to solve some of the pain around the decoupling between DevOps teams and dev teams using platforms and internal platforms and other solutions like that. But eventually, if you kind of go back in the development lifecycle all the way to the beginning, you have programming languages, right? Like, that's the first tool that developers use in order to design, to express what they want from the system. And you look at the reality of the cloud, and you realize that basically the programming languages that developers use to build applications for the cloud, they're all designed around the programming paradigm where your computer is a single machine, right? Like, even cloud native, quote unquote, languages like Go or Rust, which were designed after the cloud have emerged, they are still designed around the same kind of idea that you write your code, you compile it, you get an executable, and you run it on a machine, right? Like, that's basically the boundaries. And different programming languages have different ways to support applications that are built in the cloud, but eventually it comes down to the point that when you're writing an application using any of the, I'll call them traditional programming languages, the compiler sees only what's happening inside a single machine every time. And the reality of the cloud is completely different at this point. A cloud system, a cloud application is a distributed system, right? So your code is already running on multiple machines and on multiple compute platforms in, Lambda functions or containers or jobs or whatever. The other part is that your code intimately depends on cloud services in order to operate. And those cloud services are not external to your code. They're part of your system, right? Like, if I have a bucket or a queue or a topic or, or any other service that I'm using as part of my application, those services are part of my application. They're not an external thing. And so long as we're thinking about them as an external thing, we're unable to actually well integrate with them, right? Like, we're integrating them just downstream, right? Like, I'm writing my code and then I have to deploy it so that I can integrate with this cloud service and see if it's actually working. And so the whole idea is to basically move everything to the programming language, bring the cloud into the programming language so that both infrastructure resources and all of the runtime code of your application, doesn't matter where it's executed, is modeled in the same code base. And we have a single compiler that understands the entire picture, right? It understands that this Lambda function is interacting with this resource called, with this queue or with this bucket. And when it's interacting with them, it's performing certain operations on that bucket. And so now the compiler can take care of all the complexity, right? Like it can say, oh, I see that this Lambda function is putting a file in the bucket. That means that it needs an IAM policy that allows it to perform these specific operations on this specific resource. And that's just an implementation detail, right? Like it's not even something that the developer needs to say explicitly, because they just already told the compiler that they want to put a file to the bucket, right?
Yeah, so I had a look at the ethos, the design tenets of Waylang. I suppose that's what you mean when you say it should have batteries included, right?
Batteries included comes from a different aspect of the design. It's basically saying I want the tool chain to just contain everything, right? I don't want to need to install the compiler and the package manager and the linter and the formatter and the ID extension. And like the reality, that's, as we're designing and building this new programming language, we're trying to think in a modern way, right? Like, and kind of looking back at the JavaScript and TypeScript ecosystems, and I'm like, oh my God, this is horrible. You want to get started with a project, you need like 10 different tools and combine them together with these like intricate configuration files, just in order to build this, just to get started. And so that's where this is coming from. Like, it's like, this needs to be batteries included, in the sense that it's you don't need to go to the shop.
The environment that you're setting up itself is batteries included.
Yeah, exactly.
Yeah.
The
Okay.
development environment.
And so what we've talked about just now is kind of the implicit dependency resolution. It's the same problem that you mentioned before with the VPC, where you just wanted a Redis cluster, and now you needed the VPC, and now you needed a way to egress, and you needed root tables, and you needed NACLs and whatnot. Is there a term in the industry for that kind of implicit dependency resolution thing?
Not necessarily. I think that the other way that we're thinking about it sometimes is dependency injection, which is something that people commonly use in programming languages. Or
spooky though.
What's that?
It sounds spooky though. The word injection sounds like I don't know. It's reminiscent of SQL injection. Sounds like an attack to me.
I'll explain it concretely, right? And again, Wing. One of the interesting things we were doing with Wing or Winglang is you can write code in a portable way, because it's almost a side effect of some of the decisions that we made. Like, and let me explain. So when you're using Winglang, with Wingrun, we are shipping a standard library, an SDK, like every programming language. And as we've been thinking about, okay, so what does this SDK needs to contain? So obviously it needs to contain all the standard stuff that you expect from a programming language, but it also needs to contain some standard cloud resources. Because the goal of a standard library in programming languages is to abstract the platform that you're using, right? Like when I'm writing a file in Node.js or in Java or in .NET, I don't care if I'm running on Windows or on Linux, right? I can just write a file. And because I have this SDK, this standard library that abstracts away the platform. And if you're thinking about this as a cloud programming language, it's like, what's the platform? What's the operating system? The operating system is the cloud provider. It's like AWS or GCP or Azure, or your local machine. One of the goals for Wing was to bring back this creative flow, right? Like give developers the ability to iterate very, very quickly on their entire cloud applications on their local machine, no internet required. And so being able to actually write code that we can simulate locally very easily requires this abstraction layer. And so now when you're doing new bucket in Wing or new queue, you're basically instantiating something that's abstract, right? Like you're not saying I want an SQS queue or I want an Azure bucket. you're basically saying, I want a cloud queue. It's an abstract class in a way. And that's a cool idea, right? Like I feel from a language design perspective, in Wing, you can literally instantiate abstract classes, which is I don't know that other programming languages have that idea modeled like that. Most programming languages don't have support for that in the language. Usually there's some kind of a dependency injection framework that people commonly use. And that takes care of these types of use cases where you say, give me something that implements this interface, and then later on you bind, you provide the implementation for that dependency injection system. So Wing has that built in order to support this portability, right? Like, so you can actually compile a Wing program either to run locally, to run on AWS, to run on Azure, to run on GCP. The same code will run on all of those systems in the same way.
I see. So I'm gonna tell you how I'm picturing this, just from my very cursory reading and your explanations, and then you can correct my interpretation. Let's say I want to.
I'll say it the other way around. You'll explain how you'll tell me how you understand it, and then I'll go back and fix everything that we're doing wrong about how we explain it. Because it's hard. It's really hard. Like, I feel like one of the challenges in this project is that it's because we're shifting something on the left, in a sense, we're changing something very early in the.
It's a new paradigm.
Yeah, then lots of value is created downstream. And so sometimes it's really hard to kind of like find the thing that makes most sense as the first. Anyway, go on. I'm listening.
Yeah. So I'm picturing that if I want to write an application that has some code of its own, and it will leverage some cloud resources, I can write all of that in my one Winglang project. And the Winglang compiler, if I tell it, for example, compile this for AWS, it will write some of the actual logic. So what would traditionally have been the actual programmer's programming code, it might make that into an Lambda function, or it might compile that straight into a binary that runs on Linux and deploy it on an EC2 instance. And other parts of my code, it will kind of implicitly figure out what the dependencies are, maybe provision an API gateway to then point to the Lambda function or point to the EC2 instance, and it'll also ancillary configure the firewall rules, the listeners, and all that kind of stuff. So different parts of my code, whatever that looks like inside the project, but in that single project, different parts of my code will be treated completely differently. Some of them will literally be compiled into an executable for some sort of classic operating system. Some of them will be kind of taken as is and be script languages, for example, on a Lambda function, and some of them will not be mapped to actual code at all, but will result in cloud resources being provisioned.
Pretty close. No, it is pretty close. I feel like it's simpler than what you're describing, which is,
okay,
I hope, better in a way. Like the way when you're compiling a Wing program, you get an artifact that contains Terraform and JavaScript.
Okay.
And so the Terraform is basically the cloud infrastructure of all the resources that you need for your application. And if you compile it to AWS, it will be AWS resource. If you compile it to Azure, it'll be Azure resources. And we'll also support multi-cloud situations where you can use resources across multiple clouds. But eventually you get a Terraform file that you can go and apply through standard Terraform tools, right? And then the JavaScript is basically a bunch of JavaScript programs that will be executed inside compute platforms in on the provider of your choice. And so some of them will be run inside a Lambda function, some of them will be run in containers, but for now we're just outputting JavaScript, Node.js, basically Node.js programs, right? So it was pretty close. I think the other thing that maybe also a bit, simpler than what you described is like, we're not trying to implicitly deduce too many things about your architecture. Like the way I see it is that the idea is not to hide the infrastructure from the developer. The idea is to give the developer the ability to use the infrastructure in their application more naturally. So, the same way as a developer, you're, instantiating a hash map or a dictionary or an array, right, in memory inside your machine. And it's an abstraction, right? Like there's some RAM being allocated and some data structure that's being created inside this RAM. All of that stuff is completely hidden from you. You're just doing new dictionary, right? And so the same way with the cloud, right? Like you want to you want to use a bucket, you can just do new bucket. And behind the scenes, it implies that you need an S3 bucket. When you're compiling to AWS, you need an S3 bucket. It needs to have certain permissions. It needs to have certain, configuration, the way you're interacting with it, using some certain clients. All of that stuff that's the stuff that we're abstracting. But it's not like you're just going to write some code, at least not in the first layer, right? Like it's like any programming language, you can build abstractions. And so as you build abstractions, you can create more and more magic. But the first layer of Wing is pretty low level in a sense, right? Like it's basically, here are a bunch of building blocks. Now you can use these building blocks to build distributed cloud applications, use certain sets of standard resources that are commonly used in cloud services. And we take care of a lot of the details of how to implement those resources on certain targets. And so I think like that's another thing, right? It's not about implicitly deducing a lot of stuff about your infrastructure, because I feel like it's really important. Eventually, it is important that developers understand the constraints and the implications of building a distributed system, right? Like I'm not trying to say that you can build your system as if it was running on a single machine, and eventually you will figure out everything in order to make it work on the cloud, because I don't really believe that that's a good engineering model.
Yeah, no, I agree. And some of the kind of concerns I was thinking about is if you were hiding too much from the developers and kind of coddling them too much and basically having the approach of, you don't need to worry your pretty little head about this, we'll take care of that, that could only backfire. And if I think about some other high-level languages and so people who don't really understand them might inadvertently do really inefficient stuff. Like if you have some structure that you need to run a binary search on, and you decide to go with a linked list just because you don't really understand how any of it works, 1 or 2 levels below, that's going to be terrible. So it's good to see that you have an approach of empowering the developers, really, not coddling them, but just giving them more responsibility, but just a way to manage that responsibility more easily and more at scale.
Yeah, the other part of this is that I feel like the responsibility of the developer versus the responsibility of the DevOps engineer, the IT engineer, the SysOps, or whatever, that part of the system is, you call it. Wing has this idea of compiler plugins, and the way I sometimes think about it is that developers work above the abstraction and plugins work below the abstraction. And so technically, when you're compiling a Wing program, you can attach plugins that will completely customize everything about how your infrastructure eventually looks like. And so let's take an example. I want all my buckets to be encrypted. And that's a concern that belongs not to the developer, that's a concern that belongs to the infrastructure team, right? And so the developer doesn't care if the bucket is encrypted. And so they should just create buckets and use them as they see fit for their application. They should understand that that's a bucket. They should understand that it's a distributed component, etc. So there are some constraints from the distributed system that developers have to understand, exactly like the example of the linked list and the, but eventually you can, the platform team or the infrastructure engineer can give the developer a plugin, and then they can attach it to the compiler. And when they compile to the cloud, the plugin will just go and make sure that all the buckets are encrypted. And the plugin actually works at below the abstraction. So the plugin can actually use any specific, provider-specific capabilities that they need, or tweak anything that they want eventually below the abstraction that the developer works at. And so I feel like creating that boundary is a huge empowerment for both sides, right? Like, because it gives both disciplines the ability to apply their concerns at the right level, right? As opposed to having to, every developer now needs to make sure that every bucket that they provision is always encrypted. And if they don't, then we run some tests to make sure, and they give them training to understand how encryption works, right? Like, that's completely inefficient, right?
Yeah, that makes sense. Which brings me to the next question, and it's I think it's an interesting one, and it's also the one that I've read most online. Why did you decide to make this a new language rather than just a framework for an existing language such as JavaScript, especially seeing as a lot of it is JavaScript or TypeScript compatible and leverages JavaScript and TypeScript?
So the answer is that existing languages can't really express the idea of cloud applications. That's the reality. The concept of distributed computation, JavaScript and Node, and is not designed to express this idea that a certain function is executed in a completely different isolation boundary. Now, I could say, oh, here's a function, and I think there's some really cool examples, like Pulumi is doing something very similar. They call them magic functions, where you can actually write your handler code inside your Pulumi code base. But it's, for lack of a better word, it's a hack in a sense, right? Because what happens is that you look at the Pulumi engine basically looks at this function, and it serializes the code inside this function, but then there's no disciplined way to interact with the environment. And so you can create a variable outside of this function and reference it if you want. And then the semantics of that interaction are completely undefined, right? And so you move a lot of responsibility to the developer back to the developer in order to understand, oh yeah, this function is actually running outside of this scope, and I need to make sure that I'm serializing everything that goes in and everything that goes out. And so it's a leaky abstraction in that sense. And so that's just one example, right? The other example is cloud resources. This idea that a cloud resources has two phases of when you're building stuff for the cloud, you actually have two phases in your execution. There's the deployment phase, and there's the execution phase, the runtime phase. And when you're interacting with these resources during deployment, you're interacting with their control plane. You're interacting with the configuration of the resource, of the system. And so and when you're interacting with a resource at runtime, you're interacting it with the data plane. You're actually saying, so a good example would be when I'm defining a bucket, I can define whether it's encrypted or not, or whether it's public, it has public access or not. That's stuff that belongs in Wing. We call it the pre-flight phase, right? Like, it's before you're actually running. There's complete API that you can interact with these resources and configure them. And then when you're actually interacting with the resource at a runtime, a bucket would have put and get and list and other sets of APIs. And so in Wing actually has this idea of multiple interfaces for a class, which is again, doesn't exist in JavaScript, doesn't exist in TypeScript. And you can say, well, okay, you can put just the union of all that interface, and the developer would need to understand that they can call this here and they can't call this here. But again, that's a leak, right? That's an abstraction leak. And so forth and so on. Actually, Wing has multiple aspects that are related to cloud programming and designed specifically for cloud programming that, again, you can add more frameworks and more libraries and more tools to your tool chain and more rules of how to interact and more type, maps. But the whole idea is to simplify. The whole idea is to reduce the complexity and give developers the ability to use the cloud with much, much less learning curve than exists today. And again, I've built the CDK to support 5 different programming languages. Like when we started to build the CDK, I was like, we need to make sure that this is supported in every programming language that, or in popular programming languages, so that it's accessible to as many people as possible. And we created this technology called JSII to support this idea. And, I'm the first person to attempt to support, to do what AWS calls meet developers where they are, in a sense. But eventually I realized that there's a limit to what you can do with the existing languages because fundamental assumptions of those languages. And Wing is basically an attempt to release the shackles of the old world, right? You say, okay, the cloud is here to stay. It's a programming paradigm. It's a new programming paradigm. It's kind of like object-oriented programming was, initially I used C to write object-oriented systems. And it was really fun, right? Like you could write these structs, and every function would take the first parameter, and you can make vtables and all that stuff. But that's a great example of a leaky abstraction, right? Like as a developer, you had to understand how all these layers work under the hood in order to be able to use this idea of object-oriented programming. And then slowly, programming languages started to support object-oriented programming as first-class citizens and within the language. And object-oriented programming was democratized, right? Because that allowed more people to access this new paradigm without having to understand how to craft vtables, right, in memory. And I feel like this cloud is just going through the same process, right? Like there's this new paradigm. We even call it sometimes cloud-oriented programming, right? Like it's like I'm thinking about how to solve problems very differently than I used to think. And programming languages just didn't catch up at this point. And so Wing is kind of like the C++ of the cloud in a sense. Like it's the first time someone's trying to design a language that's tailored for this new computing paradigm. And I know it's a very, ambitious, audacious or whatever, right? Like it's a very big goal. Obviously, I'm not underestimating it. Believe me. If we could have built this as a framework, we would have. But I feel like when you see this in action, I mean, I'm just excited every time I see this because it's just, you can just feel this like relief of all these layers and baggage and tools and things you have to know and understand in order to build these complex applications. Just like changes the game in my mind.
So your new programming language feels like a good therapy session.
Yes, especially if you've been traumatized, right?
All right. 2 more questions. I want us to walk through a very, very simple but concrete example of a distributed app and how you'd program that in Winglang. And it's entirely possible that the whole premise is already flawed, in which case we can talk about that. Let's say I was thinking about the simplest thing I can do. I want a kind of 2-tier application. One is one or more compute instances, whatever it is, that generate the random number, put it into a queue, and the second one reads it from a queue and multiplies it by 2. It's absolutely pointless, but it's simple. Am I already thinking about this wrong?
No.
Okay. So how much code would you need to write in Winglang? And as a proficient Winglang developer who understands this new paradigm, how would you think about it?
So basically, you need some kind of a compute resource to generate the numbers, right? And Wing currently supports one compute resource type called function, which is, kind of akin to a Lambda function or to a Azure function. But our SDK will support a service as well, which is kind of like a long-running compute. And it would map into a container, right? In your probably some kind of a VM, a container, Fargate, or whatever is supported by your provider. And so in your case, if you want something that will continuously generate these numbers, then I would use something like a long-running service, right? Like I would use something like a service. And so you'd basically write something like, let's say you have n is the number of workers, right? And so you do something like for I equals 0 to n, new service, right? There's a resource called service. So it's going to be new.cloud.service. And then within the cloud.service constructor, you'll pass in what we call an in-flight closure, which is similar to a function closure in existing languages, but it's something that runs in the cloud, right? Like it's this distributed isolation boundary. And so within that line of code, you say new cloud.service in-flight closure. And then within this in-flight closure, you just do while true, and then, generate random number. And then you'd need a queue to push it into. So before this for statement, I would just create a queue. So you say let queue equals new cloud queue. So now I have a queue object called queue. And then within this in-flight closure, right, I would just do queue.push and put the random number. Now, even so far, just imagine what's going on behind the scenes, right? Because this queue thing is a resource, is a cloud resource that's provisioned by Terraform or by CloudFormation or by some provisioning engine. And inside my container, inside my service, I'm interacting with that resource just by calling a method, right? I'm just a queue.push. And that queue.push translated into, okay, I need to bring the SDK. I need to instantiate it. I need to know the queue URL. I need permissions so that I can actually perform this. And so all of that stuff is completely implicit because, again, I've said everything I need to say, right? And then maybe sleep 500 milliseconds and loop again. So that's what's going on inside your in-flight closure. And then on the other side, what you want some kind of a consumer for the queue, right? So you just write at the end after all this if statement, a for loop, you'd basically write something like queue.addConsumer, and then you can pass in another compute resource. Let's say you pass in a Lambda function, right? So you say new Lambda function, new cloud function, and another in-flight closure. And that in-flight closure would basically take in a parameter that's the random number. And so you'll take that random number, you'll multiply it by 2, and you'll put it in a log or something like that. So I think overall, I would say 1, 2, 3, 4, 5, 6, 7 lines of code, 8 lines of code for this entire system.
Yeah.
And you can run it locally. And so we have this simulator and we have a graphical visual tool that will show you the architecture as you're writing your code in real time. It's just like hot reload it. Every time you save your code, it'll just pop in to existence and you can run it and test it and check that it's working and it's doing what you want. And then you can go and just run wing compile target AWS and you'll get a Terraform file and JavaScript file and you go Terraform apply and it'll be deployed to your cloud provider.
Wow, that's fantastic. I feel like this has really helped me understand because looking at it like this, it's literally like I'm provisioning a local queue which would just, have been a bit of memory on my system, and I'm interacting with that like I would if I wrote a program locally, but it's all distributed. Yeah. I feel like this has really helped me. And now I have a million more questions. I'm wondering about, do you have any cool features for kind of rolling deployments and upgrades? Can I use existing resources, like if the queue already exists? Mm-hmm. Can I import that somehow? how are you planning to monetize this at all, or is it just really because it's a really cool project? But I hope, because we are out of time, I hope the listeners will feel the same, and then we'll leave them wanting a bit. They can go and do their own research if they're as intrigued as I am now. So one last question, and then we'll call it a day. Do we call it Wing or Winglang?
Either. Winglang is great. And yes, I think all those questions that you asked are relevant and interesting, and we can answer some of them, and some of them we still don't know. And I invite anyone to kind of hop into our Slack channel and chat with us and ask questions and let us know, what do you think? And it's very early, right? Like we're still in alpha.
Yeah.
And so it's a great time to shape where things are going and help us kind of make decisions about what's the right thing to build next. And there's actually kind of like a growing contributor community that are helping with the project, and it's really amazing to see everybody, everyone that's involved already, and the team is everybody, all of us are really, really passionate about this project and excited about the potential. So inviting everyone to participate.
Perfect. So where can they find you? Winglang.io?
Winglang.io or winglang/wing on GitHub.
Perfect. If anyone's interested, go and have a look. Elad, thank you so much for being on this episode. And who knows, maybe we'll record another one in a few months.
Thank you. Great to be here. See you.